So let's consider this topic called circle geometry. Yeah, we need to understand what a circle is and some parts of a circle. Okay, so let's consider the definition of a circle. A circle can be defined as locus of points, which is equidistant, which is equidistant from a fixed point. Then when we look at that, we have a fixed point, let's say point O, with a distance. And this distance can be anything, usually denoted as R. And the locus of point moving, which is equidistant from this fixed point, is what is called, okay? So let's look at some parts of a circle. Consider some part of a circle. We have parts of circle. I want to consider them one after the other. The first one, we have circumference. And we have radius. We have diameter. We have a chord. We have an arc. We have a sector. We have segments. So these are some part of the circle, and let's consider what this one means. Now, what is a circumference? A circumference is just a distance around a circle. Like we have a circle this way with center hole. So the distance around the circle here is what is called circumference. And also radius. Radius can be defined as the distance from the center of the circle to any point on the circumference. So when we draw a line from the center to any part of the circumference, so this line drawn is referred to as radius. So that is a radius. It could be to any parts. It could be from here to here. So it still means the same thing as radius. Then, what is a diameter? A diameter is a line that passes through the center of a circle and touch the circumference at both sides. So we draw a line that passes through the center of a circle, touch the circumference at both sides. If we extend this one to the other side, this way, it means this line drawn is now a diameter. It passes through the center and touches the circumference at two sides. But here, it's interesting to know that from the center to circumference is radius, also from center to radius here is a radius. So we have two radius. So we can say diameter is also equals to r plus r, which is 2r. So that is a diameter. Then also we have a chord. A chord is a line that touches a circle, the circumference at 2 points. So when we have a line drawn like this, touch the circumference at 2 points, this line is called a chord. It implies that diameter is also a chord, and that's why diameter is the longest chord of the circle. All right, so that's a chord. And we also have an arc. An arc is any part of the circumference. When we cut out any part of the circumference, we can cut any one. You can cut, if you cut this from here to here, you cut it out, which looks something like this. So this is reversed to an arc. Or you cut from here to here, cut it out. It's also looking something like this. That's an arc. So that's an arc. A part of the circumference is called arc. Then what about a sector? A sector is a region bounded by two radii and an arc. Bounded by two radii and an arc. So when we have, like this one we have now, we have a radius, making two radii, and we have this arc. And label it as AB. So from the radius AO and OB. So those are two radii and bounded by this arc AB. So this region here now is what is reversed to as sector. A sector. And this shaded part is a sector, which is a minor sector. So if we remove all of that line as well, the other part as well is a sector, because it's also bounded by these two radii and this bigger arc. So the bigger sector is a major sector, while this one shaded is a minor sector. So we have what is called a sector and also a segment. A segment is a region that is bounded by a chord and an arc. So let's say this is a chord. Let's say CD or CD. This chord and this arc. This region here is what is called a chord. A segment rather. So that's a segment bounded by this chord and this arc. So this is a segment. It's also a minor segment there because it's small. So the other side, when every other thing is cleaned up, the other side is also a segment, which will be a major segment. So these are some important parts of the circle that we should be familiar with and be able to recognize and identify as far as circle is concerned. You are watching us live here at Master Team Atlas. Give us a thumbs up and share this video, and also subscribe. You are just for the first time. Now let's look at some prerequisites before we go to the theorem proper. So now, what are those things that we must know? Just like lemmas now. So we say we have some lemmas before theorem that should come first. Before we consider the first theorem, we look at some lemmas. Number one, we have a chord or an arc subtend angles at the center of a circle. So when we have a circle, we have a chord AB, this center of a circle. You have a chord AB. And if you are not talking about a chord, we might be referring to an arc. Or we have a circle with the center O, and we have either an arc. Let's say this is an arc AB. So this chord obtains two angles at the center, The same thing with this arc, also subtend two angles at the center. When we connect A to O and also B to O, so we have two angles at the center here. We have this angle inside, which is the interior angle. Also, we can call it obtuse angle that is less than 180 degrees, but greater than 90 degrees. So this angle inside here is one of the angle. We have angle AOB, which is the obtuse angle AOB. And also we have this angle outside here, which is reflex angle. So we have also reflex angle AOB. Reflex angle is greater than 180 but less than 360. So that is that. Now, also, it might not be a chord that is forming this angle. It might be an arc. So when we join this point on this arc to the center, also to the point B here, and we also forming this angle. We form this angle at the center. So we have this angle inside and also this angle outside. So what we are trying to establish here is that a chord or an arc can form angle at the center of a circle. And also, second one here as well, we have a chord or an arc can subtend angle at circumference. Let's say we have this circle, we have the center of the circle, we have this chord AB, or we might consider it as an arc, and we also label it as AB. This also can subtend two angles at the circumference, can form one at this side, and we can label this as C. Also, we form one at this side, and we label this as D. So we can say we have angle ACB at the circumference here. Also, we have angle ADB at the circumference here. So this chord forms two angles, one at the upper part and the one at the other side. Same thing here, we can form one angle here with this arc and also another one here. So making two angles here, one here and the other one here. So we can also label this as C and this as D. So we need to understand this before we prove circle. All right. So these are some lemmas we have as far as the circle theorem is concerned. So give us a thumbs up and share these videos. Okay? And subscribe in order not to miss out on our uploads.